Masonry veneer may be either anchored masonry veneer or adhered masonry veneer. In this chapter, only anchored masonry veneer is covered. Among all contemporary exterior wall cladding systems, masonry, including brick, CMU, and stone, veneer is most widely used. And within the three masonry veneer systems, brick veneer is by far the most popular system. Its popularity lies in its durability, fire resistance, and aesthetic appeal. Additionally, the system requires almost no maintenance and can be used for buildings of all heights and complexity, from high-rise to low-rise, and from simple rectilinear facades to intricate ones. Brick veneer generally consists of a single white brick wall, generally 4 inches nominal thickness. The backup wall used with brick veneer may be load-bearing or non-load-bearing, and may consist of one of the following: wood or cold-formed steel studs, concrete masonry, and reinforced concrete. Anchors. In a brick veneer assembly, the veneer is connected to the backup wall with steel anchors, which transfer lateral load from the veneer to the backup wall. In this load transfer, the anchors are subjected to either axial compression or tension, depending upon whether the wall is subjected to inward or outward pressure. The anchors must, therefore, have sufficient rigidity and allow little or no movement in the plane perpendicular to the wall. However, because the veneer and the backup will usually expand or contract at different rates in their own planes, the design of the anchors must accommodate upward or downward and side-to-side movement. Anchors for a brick veneer wall assembly are therefore made of 2 pieces that engage each other. One piece is secured to the backup and the other is embedded in the horizontal mortar joints of the veneer. Anchors must allow differential movement between veneer and backup in horizontal direction and vertical direction, but allow for little or no movement of the anchor perpendicular to the wall. Anchor spacing should be determined based on the lateral load and the strength of the anchors. However, for a 1-piece corrugated sheet anchor or 2-piece adjustable wire anchor, the maximum spacing allowed is as shown. A minimum airspace of 2 inches is required except in low-rise buildings, where a 1-inch airspace is common. The gap between the veneer and the backup wall should not exceed 4.5 inches. For low-rise structures, a brick ledge, as shown in the left-hand figure, can be used to support the dead load of the brick, where on high-rise or multi-story buildings on the right, it's common to use a shelf angle, like those shown with the red angles. Those angles are mounted at each floor on the spandrel beams. This is a schematic detail at a typical shelf angle. Shelf angles are anchored to spandrel beams or floor structures. They're located at every floor level. Notice the gap between the shelf angle and the veneer below, with the backer rod and sealant to allow for vertical movement within the wall. Whether the veneer is supported entirely on the foundation or at each floor, additional dead load support for the veneer is needed over wall openings. The lintels generally used over an opening in brick veneer are of steel angles. Unlike the shelf angles, lintel angles are not anchored to the building structural frame, but are simply placed loose on the veneer. To allow the lintel to move horizontally relative to the brick veneer, no mortar should be placed between the lintel bearing and the brick veneer. Flashing and weep holes must be provided over lintels in exactly the same way as on the shelf angles. Flashings must be provided at all interruptions in the brick veneer, at the foundation level, over a shelf angle, over a lintel angle, under a window sill. Where the flashing terminates, it must be turned up, equal to the height of one brick, to form a dam to prevent water from entering the airspace. End dams and flashing revealed by removing a few bricks of the windowsill in the row-lock course. Weep holes in the brick sill over the flashing are not shown for clarity. This is your row-lock sill. Here is your sill flashing, and it's turned up at the end below the window. Materials commonly used for flashing are as follows: stainless steel sheet, copper sheet, plastics such as polyvinyl chloride, neoprene, ethylene, propylene, EPDM, composite flashing consisting of rubberized asphalt with cross-laminated polyethylene, copper sheet laminated on both sides to asphalt-saturated paper or fiberglass felt. A fairly successful flashing is a two-part flashing comprising of a self-adhering, self-healing polymeric membrane and a stainless steel drip edge. So here's my stainless steel drip edge, and then here's my formable or flexible self-adhering peel and stick type of flashing. So the peel and stick goes over the shelf angle and over the stainless steel flashing. Weep holes must be provided immediately above the flashing. There are several different ways to provide weep holes. The simplest and most effective weep holes is an open vertical mortar joint or an open head joint. I can tell you from experience that walls that do not include weep holes, if moisture gets behind that wall and it freezes in the winter, it has nowhere to go, it will push and move the masonry, breaking the bond, and it will basically ruin the wall. This is an example of an open head joint used as a weep hole. This is an example of wicks used as weep holes. For the airspace to function as an effective drainage layer, it is important to minimize mortar droppings in the airspace. Excessive buildup of mortar in the airspace bridges the space. Additionally, the weep holes function well only if they are not clogged by mortar droppings. Poor bricklaying practice can result in substantial accumulations of mortar on the flashing. Care in bricklaying to reduce mortar droppings is therefore essential. Since brick walls expand after construction, a brick veneer must be provided with continuous vertical expansion joints at intervals 25 foot between wall panels without windows, 20 foot between wall panels with punched windows, and 10 foot from a wall corner. Joints are detailed so that sealant and backer rods replace mortar joints for the entire length of the continuous vertical expansion joint, allowing the bricks on both sides of the joint to move while maintaining a waterproof seal. The width of the expansion joint is a 1/2 inch minimum to match the width of the mortar joints. This is the end of the material we're going to cover in Chapter 28. The Chapter 28 quiz is now available.